Hi everyone, welcome back to my channel. Our topic for today is integration by parts. Integration by parts is a technique of integration. It is a very useful method that we obtain from the formula for the derivative of the product of two functions. The product rule states that if f and g are differentiable functions, then the derivative of f of x times g of x is equal to f of x times g prime of x plus g of x times f prime of x. So rearranging this, we have f of x times g prime of x equal to derivative of f of x times g of x minus g of x times f prime of x. So integrating on each side, we have integral of f of x times g prime of x dx equal to integral of derivative of f of x times g of x dx minus integral of g of x times f prime of x dx. Then, integral of f of x times g prime of x dx equal to f of x times g of x minus integral of g of x times f prime of x dx. So this is called formula for integration by parts. So a more convenient way of writing this formula is obtained by letting u equal to f of x differentiate, so du equal to f prime of x dx, and letting v equal to g of x differentiate, so dv is equal to g prime of x dx. So the formula for integration by part becomes integral of u dv equal to u times b minus integral of v du. So our aim in using integration by parts is to obtain a simpler integral than the one we started with. When using this formula, the given integral is separated into two parts, u and dv. The choice of u and dv is subject to trial and error. However, two guidelines can be stated for the appropriate choice of u and dv. So first, the part selected as dv must be readily integrable. Then the second, the integral of p du must not be more complicated than integral of u dv. The LIATE method. This method helps us to decide which part of the integrand is to be chosen as the u part and dv part to avoid wasting time and effort. LIATE is an acronym where L stands for logarithmic function, I for inverse trigonometric function, A for algebraic function, T for trigonometric function, and E for exponential function. By this rule, A function is chosen as u or db to which it is closer in the arrangement. For example, we have integral of x times cosine x dx, where x is algebraic function and cosine x is trigonometric function. So using LIATE method, we choose x as the u part, and for the db part is the cosine x dx. Now, we should remember that this technique is not perfect. There are exceptions to LIATE method. Sometimes, something completely different needs to be considered. Number 1. Evaluate the integral of x ln x dx. So for this example, we have product of two functions, x times ln x. So we're going to use integration by parts. So first, determine the substitution for the u part and dp part. So always remember that db part must be readily integrable, or it is easy to integrate. So for this example, let u equal to ln x, and db is equal to x dx. So for the u part, differentiate. So du equal to dx over x. For the db, integrate on each side. Integral of db equal to integral of x dx. So that is a v equal to x squared over 2. Then, using integration by parts formula, we have integral of x ln x dx equal to u ln x. So ln x times v, so x squared over 2 minus integral of v x squared over 2 times du. So dx over x. Simplify. So ln x times x squared over 2 minus integral of, cancel, x over 2 dx. So as we can see, the BDU, or integral of x over 2 dx, is simpler than the integral of udb, which is the given integral. So simplify. So we have x squared ln x over 2 minus, using constant multiple rule, 1/2 times integral of x dx. Then x squared times ln x over 2 minus 1/2 times integral of x dx, times x squared over 2 plus c. Simplify. So x squared ln x over 2 minus x squared over 4 plus. Number 2, evaluate the integral of arcsin x dx. So we're going to use integration by parts to evaluate this kind of integral. So let u equal to arcsin x, and the db part will be the dx. So for the u part, differentiate both sides. So du equal to derivative of arcsin x, so 1 over 1 minus x squared dx. For the db part, integrate each side. So integral of db equal to integral of dx. So we have v is equal to x. So using integration by parts formula, integral of arcsin x dx, equal to, u So times b, so we have arcsin x times x minus integral of v du. So v, so x times du. So we have 1 over square root of 1 minus x squared dx. Then we have x arcsin x minus integral of. So we're going to rewrite 1 over square root of 1 minus x squared into 1 minus x squared raised to negative 1 half times x dx. So the video part is integral of 1 minus x squared over raised to negative 1 half x dx. So it can be evaluated using substitution method. So let's say w is equal to 1 minus x squared. So differentiate. So dw is equal to derivative of 1, 0, derivative of negative x squared, negative 2x dx. Then divide both sides by negative 2. Cancel. So negative dw over 2 is equal to x dx. Then substitute. We have x times arcsin x minus integral of w raised to negative 1 half times x dx, so negative dw over 2. Then x arcsin x. So using constant multiple rule, so we have plus 1 half times integral of w raised to negative 1 half dw. Then integrate. So x arcsin x plus 1 half times w raised to negative 1 half plus 1 over negative 1 half plus 1 plus c. So we have x arcsin x plus 1 half times w raised to 1 half over 1 half plus c. So cancel. So x arcsin x plus w raised to 1 half plus c. Then substitute the value of w, and w raised to 1 half is square root of w. So we have x times arcsin x plus square root of 1 minus x squared plus c. Number 3, evaluate the integral of secant cube x dx. So first, rewrite the integral into integral of secant x times secant squared x dx. So we have products of two trigonometric functions. So we're going to choose what is u and what is the db part. So always remember the two guidelines for choosing u and db part. So number 1, db part must be readily integrable. And number 2, integral of b du is simpler than integral of u db. So if we let u equal to secant squared x and db part as secant x dx. Differentiate the u part. So du is equal to 2 secant x times derivative of secant x. So secant x times tangent x dx. So simplify. Du is equal to 2 secant squared x times tangent x dx. Then for db, integrate each side. So db, integral of dv times integral of secant x dx. So v is equal to ln of secant x plus tangent x. Then, so using formula for integration by parts, so we have integral of secant cube x dx, so equal to u times v. So u secant squared x times v, so ln of secant x plus tangent x minus integral of v du, so v, so ln of secant x plus tangent x times du. So 2 secant squared x tangent x dx. So as we can see that the BDU in this example is more complicated than the UDB, so which is the given integral. So in this case, so we will not use this substitution. So we're going to use u is equal to secant x and db as secant squared x dx. So for the u part, differentiate. So du is equal to derivative of secant x, so secant x tangent x. For db, so integrate each side. So v is equal to integral of secant squared x dx is tangent x. So our integral of secant cube x dx, so by integration by parts, so that is u times v, so secant x times tangent x minus integral of v du, so v, so tangent x du times secant x tangent x dx. So simplify. So we have secant x times tangent x minus integral of secant x times tangent squared x dx. So our integral of secant cube x dx is equal to secant x times tangent x minus integral of secant x times tangent squared x dx. So next, so we're going to use a trigonometric identity. Tangent squared x equal to secant squared x minus 1. So we have secant x times tangent x minus integral of secant x times tangent squared, so that is secant squared x minus 1 dx. So multiply. So secant x times tangent x minus integral of secant cube x minus secant x dx. And using sum rule, so we have secant x times tangent x minus integral of secant cube x dx. Then negative times negative, so positive, so plus integral of secant x dx. No? So that is equal to secant cube x dx. So next, so transpose this negative integral secant cube x dx to the left side. So we have integral of secant cube x dx plus integral of secant cube x dx, so equal to secant x times tangent x plus integral of secant x dx. So add, so that is 2 times integral of secant cube x dx, so equal to secant x times tangent x plus integral of secant x dx, so that is ln of secant x plus tangent x plus c. Then multiply both sides by 1/2 to cancel. So the integral of secant cube x dx is equal to 1/2 times secant x tangent x plus ln of secant x plus tangent x plus c. Example number 4, evaluate the integral of x squared times e raised to x dx. So we have product of algebraic function and exponential function. So for this example, we're going to use the LIATE method. So we're going to use this method to choose what is u part and what is tb part. So for a u part, so a is closer to u. So algebraic function is our u part. So u is equal to x squared and db part is the exponential function. So db is equal to e raised to x dx. So differentiate the u part. So du is equal to 2x dx and db part, integrate each side. So v is equal to e raised to 8x. So integral of x squared times e raised to x dx is equal to u times b. So x squared times e raised to x minus integral of p du. So e raised to x times 2x dx, or we have x squared times e raised to x by constant multiple rule. So we have minus 2 times integral of e raised to x times x dx. So RBDU contains another product of two functions. So e raised to x times x. So we will apply integration by parts to this integral. So we should always remember, so it may happen that a particular integral requires repeated applications of integration by parts. So, BDU, so that is integral of e raised to x times x dx. So, using LIATE method, so u part is the x and dv part is e raised to x dx. So, differentiate. So, du is equal to dx. dv part, integrate each side. So, v is equal to e raised to x. So, integral of e raised to x times x dx is equal to u times b. So, x times e raised to x minus integral of v du. So, e raised to x times dx. So, that is equal to x times e raised to x minus integral of e raised to x. So, that is e raised to x plus c. So, integral of e raised to x dx is equal to x times e raised to x minus e raised to x plus c. So, we will substitute to this integral. So, we have integral of x squared times e raised to x dx, so equal to x squared times e raised to x minus 2 times, so integral of e raised to x times x dx is x times e raised to x minus e raised to x plus c. So simplify. So x squared times e raised to x minus 2x e raised to x plus 2 times e raised to x plus c. Five, evaluate the integral of sine of ln x dx. So, by integration by parts, so let u equal to sine of ln x and the db part is equal to dx. So, u part differentiates, so du equal to derivative of sine of ln x. So, derivative of sine is cosine of ln x times derivative of ln x, so dx over x. Then, for the db part, integrate on each side. So, integral of db equal to integral of dx. So, v is equal to x. Then, by integration by parts formula, so sine of ln x dx is equal to u times v. So, sine of ln x times x minus integral of v du. So, v is x times du. So, cosine of ln x times dx over x. So, cancel. So, we have x times sine of ln x minus integral of cosine ln x dx. So we have another complicated integral. So we will call it as equation number 1. Then, so this integral, so to evaluate this, so we're going to use integration by parts. So we have integral of cosine of ln x dx. So u is equal to cosine ln x, and tv is equal to dx. So differentiate. So du is equal to derivative of cosine ln x, so negative sine of ln x times dx over x. Then dv part integrate, so dv equal to integral of dx, so v is equal to x. Then integral of cosine of ln x dx is equal to u times v. So that is x times cosine of ln x minus integral of v du. So x times negative sine of ln x times dx over x. So cancel. So we have x cosine ln x plus integral of sine of ln x dx. So we will call it equation number 2. Our equation number 1 is integral of sine of ln x dx equal to x times sine of ln x minus integral of cosine ln x dx. Then equation number 2, integral of cosine ln x dx is equal to x times cosine ln x plus integral of sine of ln x dx. So substitute equation 2 to equation 1. We have integral of sine of ln x dx equal to x times sine of ln x minus x times cosine ln x plus integral of sine of ln x dx. Then multiply. So x sine of ln x multiply minus x cosine ln x minus integral of sine of ln x dx. Transpose negative integral of sine of ln x dx to the left side. So we have integral of sine of ln x dx plus integral of sine of ln x dx equal to x times sine of ln x minus x times cosine of ln x, and we have 2 times integral of sine ln x dx equal to x sine of ln x minus x times cosine of ln x. Then multiply both sides by 1/2. No cancel. So the integral of sine of ln x dx is equal to 1/2 times x times sine ln x minus x times cosine of ln x plus c.